So at this point, the only techniques that we have for integrating functions are using antiderivative formulas and the substitution method. So now we're going to start developing and working through some problems where we're going to use more advanced techniques of integration. The first one being a technique called integration by parts. And to kind of get an idea of where this formula comes from, I thought we'd revisit a problem from Calc 1. So what if we were asked to differentiate the function f of x equals x times sine of x? How would we do that? Well, hopefully you remember that if you're trying to take the derivative of a function of a product of two functions of x, then we use the product rule. And you may use a different notational device depending on how you learned it, but what I tend to do is I break this up into u and v. So I say u is going to be equal to x, and v is going to be equal to sine of x. We then take the derivative of each of them, so the derivative of x is just 1, and then the derivative of sine of x is cosine of x. And we know that the product rule tells us that f prime of x is going to be u prime times v, the derivative of the first times the second, plus the first times the derivative of the second. And now we just go ahead and we plug in our u prime, and v prime to get our derivative. So that would make f prime of x be 1 times sine of x plus x times cosine of x. And we could clean this up a little bit and just say that our derivative is the sine of x plus x times the cosine of x. Okay, so that's how we take derivatives of products of functions of x. So what if we wanted to integrate x times sine of x with respect to x? Well, what we should be doing at this point is, now that we're going to start building up a toolbox of different methods to integrate, let's run through the easy things first to make sure that we can't get out of this a little bit easier than some other rules. So the first thing we want to ask ourselves is, can we use an antiderivative formula? So antiderivative formula. So we go through our list, either in our head or if we're doing homework on paper, and we see, is there a formula that matches this? In this case, no, there's not. So we've got to move on. The other technique that we've got that hopefully we're pretty comfortable with at this point is substitution. So is there a way that substitution would work? And ideally we'd be looking for, will substitution work easily? Sometimes we can kind of bend it around. In this case, it's really not going to work for us. We can't let u be x because we wouldn't be able to, we'd have the same function back, and sine of x, there's no cosine to get our du, so in this case substitution would also fail us. All right, so this is how we come about developing our new technique of integration. And this is just a little proof if you kind of want to see, if you like to understand the justification for things. So if we were to consider two functions, so two functions of x, let's call them f of x and g of x. Okay, so we know from the product rule that if we were to take the derivative with respect to x of f of x times g of x, that this would give us f prime of x times g of x plus f of x times g prime of x. So this is just a statement of the product rule right here. Nothing new here. Now we want to develop an integration technique, so what we're going to do now is we're going to integrate both sides of this. So that would give us the integral of the derivative of f of x times g of x, and we're going to integrate with respect to x, and then we're going to take the integral of f prime times g of x dx, and then we're going to take the integral of f of x times g prime of x. We're going to integrate that with respect to x. Now, a couple things we can do to simplify. We recognize from the fundamental theorem of calculus that integrating the derivative of a function essentially sort of undoes it. So this first expression, we could just say that integrating the derivative is just going to give us f of x times g of x. And there's obviously going to be a constant of integration floating around, and we'll worry about that a little bit later. And then we still have these integrals. So f prime of x times g of x dx plus the integral of f of x times g prime of x dx. Now, what I'm going to do is I am now going to, it really doesn't matter which one we subtract from both sides, but conventionally I'm going to choose to subtract the integral of f prime of x times g of x dx from both sides. So if I subtract it from this side, and if I subtract it from the other side, what we end up with now is we have the following statement, that f of x times g of x minus the integral of f prime of x times g of x dx is equal to the integral of f of x times g prime of x dx. Now, this notation is a little bit messy, so if we were to make a few substitutions here, we get our formula, or the conventional formula that we use for integration by parts. So, as I noted down here, if we were to let f of x be represented by u, and f prime of x dx be represented by du, and then if we were to let g of x be represented by the letter v, and g prime dx be represented as dv, so we're kind of getting a little bit closer to what the product rule looked like, and then we just kind of flip the equality, we get this formula for integration by parts. So this is the go-to formula in terms of using integration by parts, and this is something that will need to be committed to memory. So in the next example, or the next video, we're going to go ahead and we're going to try this on a basic example, and then we're going to do a bunch more of examples.